Okay, let us see the three graphs I have drawn here for you. First of all, this graph is displacement by time. X-axis is time and the y-axis I have taken as displacement. Clear? So in this graph you will notice that displacement is the same. Displacement at this point is the same as, say, this is time. Suppose this is time on this x-axis, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds and so on. You will notice whatever the displacement was at the first second, it is the same at the third second, fourth second and fifth second and so on. Displacement of the body remains the same. So, if the displacement of the body does not change with time, what does this show? This shows that the body is stationary. The body is not moving. So, on a displacement time graph, if the displacement is not changing, we have got a horizontal line. It shows a stationary body. Okay, remember this. And now we will just change the y-axis. If I change the y-axis and instead of displacement, if I take velocity here, on the y-axis I have taken velocity. Okay, so now this becomes a velocity versus time graph. What do we notice here? Suppose this is 1, 2, 3 and so on, which means velocity I have taken in units. Suppose the units is meters per second. So this is 1 meter per second, 2 meters per second, 3 meters per second and so on, the velocity. Okay, while the time I have taken here is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds and so on. So what do we see on this? We see that the velocity is remaining the same. So velocity was at time 0, velocity at the beginning was 3 meters per second. After 3 seconds, velocity of the body remains the same. It was 3 seconds, 3 meters per second again. After 5 seconds, the velocity still is the same, 3 meters per second. So what does this show? This shows a body traveling with constant velocity. So it is a traveling body. Remember, the displacement is hence changing because it has got a certain velocity. Velocity versus time graph, the horizontal line shows that the velocity of the body is constant. So it has got a certain displacement. It is moving with time. But what does this show? The velocity of the body has not changed. That means the body is traveling with a constant velocity. And what does constant velocity mean? Constant velocity means that the acceleration of the body is equal to 0. Okay. So velocity versus time graph, the horizontal line shows the body moving with a constant velocity where the acceleration is 0. So you have understood the significance. Next, let us go on to a displacement versus time graph. This is a displacement versus time graph. What does this show? Again, the time let us mark as 1 second, 2 seconds, 3 seconds, 4 seconds and so on. While the displacement of the body is suppose 2 meters, 4 meters, 6 meters and so on. In 1 second the displacement of the body was 2 meters. Clear? After 2 seconds the displacement of the body became 4 meters. After 3 seconds the displacement of the body has become 6 meters and so on. So we know displacement by time, that is the slope of the graph, isn't it? Displacement by time, that which means this one y-axis, y by t, y by x, the x-axis. So what was it here? Here it was the displacement by time was 2 by 1. 2 by 1 was the displacement by time, which is the definition of velocity, isn't it? So velocity at the beginning was 2 by 1, that is equal to 2. Then at 2 seconds it was 4 by 2, velocity was 4 by 2, which again comes out to be 2. And then after 3 seconds the displacement of the body was 6 meters. Hence displacement by time is equal to 6 by 3, which is the velocity of the body, which again comes out to be 2. So what does the graph show? This displacement versus time graph, remember, when you have got a straight line which is increasing over time, which has got the straight line shows that the slope is constant. Okay, understood? So this straight line will show that the body is traveling with a constant velocity on a displacement time graph. Remember the difference between this graph and the other graph. On the displacement versus time graph, this straight ascending line shows that the body is traveling with a constant velocity. While on a velocity versus time graph, the body traveling with constant velocity will be shown with a horizontal line. So you have understood the difference between the two. Now let us go on to another graph. This third graph is a velocity versus time graph. I have taken velocity on the y-axis while I have taken time on the x-axis. Let us take time in 1 second, 2 seconds, 3 seconds, 4 seconds and so on. Whereas velocity of the body, let us take in units 2 meters per second. Then suppose it's got then again 4 meters per second. Unit we are using meters per second. Hope you understood that. Then 6 meters per second and so on. And we have got a horizontal straight, not a horizontal line, an ascending straight line, which has got a constant slope. It's a straight line. Hence, the slope of the line does not change. So what you will notice here is after 1 second time, the velocity was 2. When the time became 2 seconds, the velocity of the body became 4. After 3 seconds, the velocity of the body became 6 meters per second, and so on. So we see that the velocity of the body is increasing at a constant rate. Is it clear to you? Velocity of the body is increasing at a constant rate, which is signified by this straight line. Hence, what does this show? This shows us that what does constant increase in velocity mean? That the body has got a constant acceleration. Acceleration of the body is constant, which means velocity of the body is increasing but at a constant rate. Is it clear? Velocity versus time graph. A velocity versus time graph, a straight line which has got the same slope will show you a body which is traveling with constant acceleration. So acceleration of the body is defined as, what is acceleration of the body? Acceleration of the body is defined as, here again, the slope of this line, which will be equal to y-axis by x-axis. So acceleration of the body will be equal to, we can take it as 4 by 2, that is the velocity divided by, this is velocity and this is time. So velocity divided by time we know is acceleration. So we can take it as 4 by 2, or we can take it as 6 by 3, and similarly here we can take it as 2 by 1. So we notice that the acceleration in each case has come out to be 2 meters per second square. Understood? Hope you have understood the 4 different graphs I just have drawn and shown you the difference. So this was a velocity versus time graph. On this graph, the constant line, a straight line which is ascending upwards, shows you that the slope of the line is constant. Hence, it shows what is velocity time graph. Velocity divided by time is, we know acceleration. Hence, it shows us the acceleration of the body is constant, but the velocity is changing velocity of the body is changing. It's increasing. Here we have noticed it was at 1 second it was 2. At 2 seconds it was 4 meters per second. After 3 seconds it was 6 meters per second and so on. So the velocity of the body is increasing at a constant rate. Hence acceleration of the body is constant. Acceleration of the body is constant. But remember, the body is gradually picking up speed. The velocity of the body is increasing with every second. So you have understood the distinction between the 4 graphs that I just drew and explained to you. Let me tell you something about the unit of displacement, velocity and acceleration. displacement of a body, displacement I am writing in short, okay? But remember the short forms I am using. Displacement, DISP, displacement of a body is measured in, the unit is meters or it may be kilometers and so on. Clear? Next, after displacement we have got velocity, velocity of a body. What is velocity of a body? That is displacement by time, isn't it? So displacement, suppose we are taking in meters and the time is taken in seconds, the units will come out to, the unit will come out to be in, what we will get is in meters per second. So the unit of velocity will be meter per second. But if in case we are taking the displacement is a larger displacement and has to be measured in kilometers, then the displacement will be taken in kilometers while the time we take in hours, okay? Because it's a larger interval of time. Hence, the velocity, unit of velocity will come out to be in kilometers per hour. Maybe 10 kilometers per hour, 20 kilometers, maybe 60 kilometers per hour and so on. Is it understood? Next, we will come down to acceleration, unit of acceleration. We know that acceleration is defined as rate of change in velocity, isn't it? Hence, acceleration is velocity divided by time. Velocity by time will give you the acceleration. Suppose we are taking meters and second, and we remember that velocity, unit of velocity was in meters per second and the time is also in second. So it becomes, then the unit of acceleration, it becomes meter by this s square, because m divided by s, then again divided by s, hence it becomes m by s square. Hence your unit of acceleration will come out to be in meters per second square. Meters per second square. Remember. And if in case we take the velocity in kilometers per hour, if it is a larger unit and hence has to be measured in kilometers and hours, then the velocity of the body will be in kilometers per hour and the time has to be taken in hours. Then what we will get, the unit of acceleration will come out to be kilometers divided by hour, then again by hour, it will become kilometers by hour square. Therefore, the unit will be kilometer per hour square. Is it understood? Hence, the acceleration is equal to kilometers per hour square. The 3 units, remember the 3 units we will use. In case of displacement, we use kilometers. For smaller distances and larger distances, we will take kilometers. For velocity, it will be meters per second or kilometers per hour. And in case of acceleration, it will be in meters per second square or kilometers per hour square. But generally, we use, in case of acceleration, we use meters per second square. That's the normally used unit. But both can be used, no problems there. Is it clear? Hope this much is clear to you. Now look at this velocity versus time graph I have drawn here. This is another type of velocity versus time graph, where I have taken the velocity on the y-axis and the time on the x-axis. The time has been taken in 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6, 7, 8 seconds and so on. Whereas the velocity has been taken in 1 meter per second, 2 meters per second, 3 meters per second and 4 meters per second. And here velocity is -1, -2. Why? What does minus show? Minus shows velocity, the body is traveling in the opposite direction. The minus sign will show the direction, signifies the direction is the opposite to what it was here. Clear? So now we have to find the total distance traveled by the body shown by this graph total distance traveled by the body we have to find out, and secondly we have to find out the total displacement of the body shown by this graph. First of all, let us find out total distance. We know that total distance can be in any direction, so direction does not matter. Therefore, the total distance traveled by this body from 0 seconds to 8 seconds will be the area of this triangle, plus the area of the trapezium. Hence, we know the area of a triangle is half base into height. The height of this triangle is 4. And what is the base? Base is 3. Hence, what is the total area of this triangle? Area of this triangle is half base into height, which means half into 3 into 4. Half into 3 into 4, which is it? Then plus the area of this triangle. The area of this triangle is again half base into height, so it will be half into base is 2 and the height is 3. Clear? The height is 3, and then plus the area of this trapezium. What is the area of a trapezium? Area of a trapezium is the sum of the parallel sides into height into half, which is half into sum of the parallel sides multiplied by height. What is the sum of the parallel sides? Sum of the parallel sides here is, this is 4, distance from 5 to 8, which means it is 4, and this is equal to 1. Sorry, 1 minute, excuse me. This is 1, 2 and 3. Here 5, 6, 7, 8. 3. The base, this is 3. Hence, that is equal to plus half into 3. Half into 3 into 1. 3 plus 1, sorry. Sum of the parallel sides, 3 plus 1 is 4, multiplied by height. Height is 2, minus 2, isn't it? So, the area of the trapezium is coming out to be 3 plus 1 is 4. 4 into 2 is 8. Half of 8 is 4. Therefore, the total distance traveled by the body is half into 3 plus 4 is equal to 6. Plus 6 plus 3 to the 6. Half of 6 is 3. Plus 3 plus 1 is 4. 4 into 2 is 8. Half of 8 is 4. Hence, the total distance traveled by the body is equal to 6 plus 3 plus 4, which means it is equal to 13. Total distance of the body traveled by the body is 13 meters. Now, let us find out the total displacement of the body. We will calculate the displacement of the body shown by this graph. In case of displacement, we have to take the direction, the area of this triangle as positive because it is in the positive direction. Similarly, this triangle is again in the positive direction, while the area of the trapezium is in the negative direction, negative sphere. Hence, we will take total displacement is equal to area of this plus area of this triangle minus the area of the trapezium. Hence, it will come out to be half into base into height again. Base was 3, half into 3 into height was 4, half into 3 into 4, plus the area of this triangle, which is equal to half into base into height. Half into base is 2 and height is 3, minus the area of the trapezium. From this, what do we find out? We know that the displacement of a body, direction is very important. And here direction is signified by the negative terms. Velocity was here minus 1 meter per second square, minus 2 meters per second square and so on. Hence, What will be the area of this trapezium is half into sum of parallel sides 3 plus 1 4 into this height. Height is 2. So 3 plus 1 is 4. 4 into 2 8 and half of 8 is 4. Therefore the total displacement will be equal to 3 4s are 12, half of that is 6. So total displacement 6 plus this is equal to 3 into 2 6. 6 half of 6 is 3. 6 plus 3 and minus the area of this trapezium. Area of this trapezium is 3 plus 1 4 into 2 is 8. Half of 8 is 4. Therefore the displacement comes out to be 6 plus 3 is 9. 9 minus 4 is equal to 5. So you have seen the difference between the distance traveled by the body and the displacement of the body. The displacement of the body has come out to be 5 meters as shown by this velocity versus time graph. So you will remember, when we have to calculate the distance traveled by the body, it will be the sum of all the areas. Whether it is in the negative territory or in the positive territory, it does not matter. It will be the sum of the three areas. This area, shaded area, plus this shaded area, plus this shaded area will be the total distance shown in the body as the body travels 8 seconds. But in case of displacement, you remember, it will be the sum of the areas of these two triangles in the positive territory, that means on the positive side of the y-axis, and hence this will be the sum of this plus this, and since this is in the negative territory, negative area of the velocity or the y-axis, this will be subtracted from the sum of the two. Hence in case of displacement, you remember, whatever is on the positive side of the y-axis will be added and whatever is on the negative side of the y-axis has to be subtracted. Therefore the total displacement of the body will be from the sum of this area plus this area minus the area of the trapezium. So we found that distance traveled by a body and displacement of a body is not the same in all cases. There is a distinction between the two and it depends upon the direction traveled by the body. Hope this is clear to you. You can do more practice problems that will be making it clear for you. I will give you some practice problems later on. Next, let us try and study the motion of a body under the action of gravity. We know that the acceleration due to gravity of a body is constant. The Earth's acceleration due to gravity, which means that the Earth's pull. We know every body is pulled towards the center of the Earth, and the acceleration due to gravity, the value we know is equal to 9.8 meters per second square is the acceleration due to gravity. Hence, now we will study a graph of a body. Suppose we have got a stone in our hand and we are throwing the stone upwards in the upward direction. Suppose we have thrown the stone up with a initial velocity of 20 meters per second. We have thrown the stone up with a velocity of 20 meters per second. We know that when the body is going up, the acceleration due to gravity of the body due to the Earth will act on it, and hence its velocity will constantly decrease as it goes up. And when the stone has reached its highest point, the velocity of the body, the stone in this case, will for a moment become 0 and then it will start falling down again towards the Earth's surface. Remember, the velocity of the body, a stone in this case, has become 0 when it reached the top, but it was thrown with an initial velocity of 20 meters per second. And when it has reached the top, it will have a velocity of 0 at that point. And again then it will start falling down towards the Earth's surface due to the action of the Earth's acceleration due to gravity, which is in other words the Earth's pull towards the center of the Earth. its value is 9.8 meters per second square. So when the stone comes up and then goes down again, remember that it will come and hit the surface of the ground with the same velocity with which it had gone up. So when it reaches the ground again, it will have a velocity of 20 meters per second. In this case, let us try and draw the graph of a ball which has been thrown up. It reaches a certain height, its velocity becomes 0, and then it starts traveling down towards the surface of the earth again and hits the point with the same velocity. Now we will try and draw the graph for such a moving body. This is the time and this is the velocity. So it is the velocity versus time graph. Initially we threw it up with a velocity of 20 meters per second when the time was 0. When time was 0, we threw it up with a velocity of 20 meters per second. Suppose this is 20 here on the y-axis. It was thrown up with a velocity of 20 meters per second. It will have a constant acceleration due to the earth's surface, so it will be a straight line, isn't it? When it reached the topmost point, its velocity became 0. Whatever the time was that you have to calculate later, you can do it later as a problem. When it reached the highest point, the velocity of the body was 0. Then again, when it is falling downwards towards the earth's surface, the acceleration due to gravity will act on it, which is a constant acceleration. Hence the velocity time graph will be a straight line, isn't it? But it is in a when the body is falling downwards, the velocity will go on increasing at a constant rate. Hence the velocity time graph will again be a straight line, isn't it? So the time taken too will be the same, just as whatever the time was while going up. Hence the velocity at this point was 0. While coming down, it will again increase. The velocity will increase, velocity of the body is increasing, and it will reach 20 at the same time interval from here to here. Suppose this distance was x and this distance too will be x. Hence this point is 2x. Okay, this point is 2x. Is this clear? This velocity time graph, this V-shaped velocity time graph shows you the velocity time graph of a stone that was thrown upwards with a certain velocity, 20 meters per second in this case. It went up, the velocity became 0 after time x, and then the body's velocity again started acting, increasing, velocity of the body started increasing, and when it hits the ground, it became 20 meters per second, the velocity became 20 meters per second after a time interval of x seconds again. Hence, what does this x-axis show you from here to here? This distance is 2x. 2x is the total distance, total time, the total time that it took the stone to travel this upwards and then downwards to this point. That is the total time taken from here to up, then up to the ground again. Is the time 2x. While the velocity at the beginning was 20 meters per second, it became 0 at this point, and then the velocity again started increasing while the ball was falling down and reached a velocity of 20 meters per second at this point at another time interval of x. Hope this velocity time graph is clear to you. Next we will study another graph. This will be a velocity versus time graph. This is a velocity versus time graph I am drawing here. On the y-axis I am taking the velocity, while on the x-axis I have taken the time. Suppose we have taken the time in seconds, unit of time in seconds, and the velocity of the body I have taken in meters per second. Let us mark the units. The units are not very important here. In case this was 0, and this is time on the x-axis. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6, 7, 8 and so on. Now let us study a body which starts at time 0 with a velocity 0. Initially the velocity was 0. After 2 seconds, the velocity of the body became equal to 2, 4, 6, 8, 10 and so on. I have marked it. Hence, after 2 seconds, the velocity of the body becomes 8. Then it travels with a constant velocity of 8 meters per second for a certain time interval. For the next 3 seconds, it has traveled with a constant velocity of 8 meters per second. Then the body starts reducing its velocity, and then the body starts reducing its velocity, and the velocity of the body finally comes down to 0. Which means, what does this mean? Negative velocity means decrease in velocity. Decrease in velocity means a negative acceleration. Negative acceleration is also known as deceleration. Negative acceleration. Negative acceleration is also called deceleration. Deceleration. When the velocity of the body is decreasing over a period of time. In this case, the area of the trapezium will give you the total displacement of the body, and if you want to know the average velocity of the body, average velocity of the body will be, you know the definition of average velocity. Average velocity is equal to total displacement divided by total time, isn't it? Now let us find out what the total displacement is. Total displacement, as we know, is the area under the graph. The area of the trapezium will hence give you the total displacement of the body from this period up to this point. Total displacement is the area of the trapezium. Now what is area of a trapezium? Area of a trapezium is half into sum of the parallel sides into its height. Hence, what is the area of this trapezium? Area of the trapezium will be half multiplied by the sum of the parallel sides. Parallel side is equal to, this was equal to, suppose 1, 2, 3, 4, 5, 6, 7, 8. This is 8 and this is 1, 2, 3. This is 3. Therefore, it will be the sum of the parallel sides. 3 plus 8. 3 plus 8 multiplied by the height of the trapezium. Height of the trapezium was 8. Hence, the area of this trapezium is equal to the total displacement of the body from this point to this point. That will come out to 8 plus 3 is 11. 11 into 8 is 88. 11 into 8 is 88. Half of 88 is equal to 44. Therefore, the displacement of the body is equal to 44 meters. 44 meters is the displacement of the body. Now divided by the total time taken. Total time taken during this time was 8 seconds. Total time 8. Therefore, average velocity of the body during this time travel is equal to 44 by 8 or equal to 11 by 2 meters per second. Hence, what did we do here? In this velocity versus time graph, we use the graph to find out the average velocity of a body traveling from point this to point this in a time interval of 8 seconds with a varying velocity. The body did not have a constant velocity during the entire time. First, its velocity went up during the first 2 seconds, then it traveled with a constant velocity, which means acceleration was 0 during this time. It traveled with a constant velocity for a period of 3 seconds, and then it started deaccelerating or decrease its velocity during the last 3 seconds. And during this entire time, the velocity of the body was changing. It was not the same, but we have been able to calculate the average velocity of the body during the time interval as total displacement divided by total time. Is it clear? Hope it's clear to you.